Welcome to the ET380 Semiconductors, Diodes, and Transistor Theory lecture. Let's look at materials and atoms. Here I'm showing a conductor, and this is a copper atom, and we see the electron is far out from the valence shell, long way from the center. This electron is very easy to be moved, and it allows conduction. Here I'm showing an insulator where the electron valence shell is full and close to the nucleus and very hard to remove, so it becomes an insulator where it won't conduct electricity. Here I'm showing a semiconductor material, this one being silicon, and our valence shell, and we have 4 electrons in our valence shell, so this is stable and will not conduct. So at this condition, it will not conduct or become a semiconductor until we do some doping. Here I'm showing an N-type semiconductor where we've taken silicon and we've implanted phosphorus. Phosphorus would make it into an N-type where we have 5 electrons, and we have our free electron. And the materials are sometimes phosphorus, antimony, bismuth, or arsenic. And this is our N-type. And we can think of it as a negative because it's got the electron, even though that's not totally correct. Here I'm showing a P-type semiconductor where we've doped this with a boron. And our trivalent elements are boron, gallium, and indium. And this leaves a hole in our circuit, so we get the hole type flow. Here I'm showing a diode. We have the symbol and our bar. Our bar shows cathode. In order for this to conduct, the arrow always has to be pointing towards ground. We have a positive on our anode with A, and we'll go to ground with K, which is our cathode. Here's a diagram of an actual diode, and we see the stripe. The stripe is this bar here, and here's our electron diagram. So we have a P-type material, which has holes, and the N-type region, which has electrons. So we're going to put a positive on this side and a negative on this side. So the negative is going to repel the electrons, and our positive is going to attract. Once we have our p-n junction here, once we have our barrier region, once that voltage is exceeded, we're going to get electron flow through our diode. Let's take a look at basic transistors. And we have complicated biasing and circuitry, but there's only 3 conditions that we look at a transistor. First one is saturation. This is an NPN transistor. And when we're in saturation, it acts like a closed switch. It is fully functioning to pass current. So one of the conditions is saturation, meaning full on. The second condition of transistors will be in the cutoff. Cutoff means fully off, no conduction flow. So switching transistors operate in saturation or cutoff, full on or full off. The next operating region would be active. It's somewhere in between, is acting basically like a potentiometer. So transistors that are used as amplifiers would be in the active region. Here I have a basic bipolar junction transistor. Here's the symbol with the arrow pointing out, NPN transistor. So we have the N region, a P region, and another N region. Collector, emitter, and the base. And our current flow of electron would be up through this direction here. Here's another BJT transistor type. This is P&P, where we have P material, N material, and P material, with N materials in the middle. We have the arrow pointing in, and our flow direction of our electrons is opposite to the NPN. Here I'm showing a bipolar transistor used as an amplifier. And we could have all this circuitry and biasing, but basically the transistor is what it's doing. It's taking voltage or current from somewhere. We put a small signal in, and we get a larger signal out. That larger signal is from our power supply. So an amplifier basically takes a small signal in and makes a larger signal out. Here I am showing a bipolar junction transistor cross section showing the areas. Here I have the emitter side. This side is heavily doped and it emits electrons into the base. Here we have the base. This is P-type material and it's lightly doped. Here I have the collector side. It is N-type and it is medium doped, and it collects electrons from the base. So here we show our base emitter and our emitter base junction diode and our collector base junction diode. So in an active operation, we have current, which is, I call it priming this area in order for us to get flow, current flow. So we have emitter current going to the collector when it's fully on. IE and IC are almost equal.